This is an online video lesson on specific latent heat. Before we look at specific latent heat, can you remember what the definition of specific heat capacity is? You may want to pause the video and have a little look. So the definition of specific heat capacity is the amount of energy needed to heat up 1 kilogram of a substance by 1 Celsius. So thinking about those two terms, specific latent heat and specific heat capacity, which word do those two terms have in common? So they both refer to the word specific, but in terms of science, what does this actually mean? So in physics, the word specific means per unit mass or per kilogram. So in both cases, we're looking at what happens in 1 kilogram of a substance. So we can refer to these as material properties, as in they tell us something about the property of a particular material rather than an object. So the definition of specific latent heat is it is the amount of energy needed to change the state of 1 kilogram of a substance. So for example, the amount of heat energy required to boil a kilogram of water. Now obviously boiling isn't the same as melting, so there are two types of specific latent heat. If we call it the specific latent heat of fusion, then that's the amount of energy needed to change 1 kilogram of a substance from a solid to a liquid. So for example, to melt 1 kilogram of ice into water. The specific latent heat of vaporization is the energy needed to boil 1 kilogram of a substance. So for example, change 1 kilogram of water into water vapor. Going back a couple of lessons then, we looked at a graph like this, which shows us how the temperature of a substance changes as we continue to heat it up. Down in the bottom left here, we've got this section where we're heating up a solid. It's getting hotter and hotter until it meets the melting point. At this point, the heat energy is no longer making the substance hotter. Instead, it's now breaking bonds so that the solid turns into a liquid until we get to this point here. Now the substance is a liquid, and as I continue to add heat energy, it gets hotter and hotter and hotter until it meets its boiling point. And once again, the temperature doesn't change because the energy is breaking bonds rather than making the liquid any hotter until we get to this point when everything is now a gas. We can return to this graph to try and get our heads around the difference between specific heat capacity and specific latent heat. So in these sections here where I am making a substance hotter, you can see the temperature is rising in each case, whether it's a solid or a liquid or a gas. Then the equation E equals mc delta theta, which includes specific heat capacity, tells me how much energy it takes to raise the temperature of that substance by 1 degree. If I look at the flatter sections along here and here, this is where we've got change of state going on. So if I look at the one at the bottom down here, this is where my solid is changing into a liquid, and the specific latent heat of fusion tells me how much energy it takes to do that for 1 kilogram of that substance. Up here I've got my liquid turning into a gas, and the specific latent heat of vaporization tells me how much energy it takes to do that for 1 kilogram of that substance. In each of those cases, the line is flat because we know that the energy is breaking bonds. It's not actually adding to the temperature of the substance. So this equation shows us how we can calculate the energy required to change the state of a certain mass of a substance. So energy equals mass times specific latent heat. So that's energy in joules, mass in kilograms, and the specific latent heat is measured in joules per kilogram. And we can rewrite that as capital E equals m multiplied by capital L. Now specific latent heat of fusion and vaporization will both work in this equation, but we have to remember that for any substance, for example water, the latent heat of fusion of water is not the same as the latent heat of vaporization. Obviously we'd expect it takes a different amount of energy to melt a substance than it does to boil it. So here is a sample calculation. If the specific latent heat of vaporization of water is 2.3 million joules per kilogram, calculate how much energy is needed to boil 2 kilograms of water. If we put the numbers into the equation, E equals ml, we end up with 2, which is the kilograms, multiplied by 2,300,000, and the answer is 4.6 million joules. So to end this lesson, I'm going to suggest you have a go at these 4 tasks, and this will help you get your head around the different definitions and equations. So firstly, write down the definition of specific heat capacity and then write down the equation that relates to it. Thirdly, write down the definition for specific latent heat and then again write down the equation relating to it, and make sure you've got all those 4 facts clear in your mind.